Hello again, everyone. I'm going to do a quick review of complex numbers, imaginary numbers, and complex conjugates. So first of all, we need to start by this general rule that says the square root of -1 is equal to I. We've always been told that you can't have a square root of a negative number. Well, we can't if we're talking about real solutions. So then we say, well, let's add in a different type of solution that's called an imaginary solution or a complex solution. And then we can have the square roots of positives or negatives. And then what we're going to do is we're going to have problems that are set up as the square root of -a, where a is greater than 0. So a is a positive. Tack a negative onto it, it's going to make it a negative. So the first step to solving a problem like this is you take the -1 out. So you factor the square root of -1 and multiply that by the square root of a, which would build back into the square root of -a. After that, you're going to factor a, so you're going to find all the factor pairs of a, and you're going to pick the largest perfect square factor pair. So you're going to have a bunch of factor pairs, you're going to have a perfect square potentially, and you could have multiple perfect squares as factors, but you want to pick the biggest one. So let's go ahead, and after that you're going to simplify. So example 1 I have here is the square root of -32. First you're going to take that square root of -1 out, and then multiply that by the square root of 32. I'll find all the factor pairs of 32, which are 1 and 32, 2 and 16, 4 and 8. Although 4 and 8, 4 is a perfect square, that's a nice factor pair. 2 and 16 is better because 16 is a larger perfect square. So I'll pick 2 and 16. I always like to rewrite this with the perfect square first, and then the part that won't simplify last. So I've got square root of -1, square root of 16, square root of 2. The square root of 16 is 4, so I'm going to have a 4 here. And then the square root of -1 is I. So those parts are taken care of. After that, I have the square root of 2 hanging around. And we can't really do much with that, so I just leave it at the end. The next concept I want to talk about is the complex conjugate of the number a plus bi. A plus bi is a complex number. And if you have a minus bi, that's going to be its complex conjugate. So if we look at this first example for those, the complex conjugate of 3 plus 4i. All I'm going to do to find a complex conjugate is take the opposite sign of the I part and then leave the rest of the problem the same. So it was plus 4i, switch it to a minus 4i, and the 3 stays the same. This next example, the complex conjugate of just a real number 3. Since I'm only switching the sign of the complex part or the imaginary part, all I have to do is just write 3. The complex conjugate is the same. Lastly, example 4, the complex conjugate of -5i. Again, all I'm going to do is switch the sign of that I part or the complex imaginary part. So complex conjugate of -5i is +5i. I hope this helped clear these topics up a little more. Have a great rest of your weekend, and I'll see you Monday.